The last solution method we're going to look at is a method where we're called using the addition method. Addition method. Now the addition method is probably the more powerful of the two that we're looking at, but substitution is funner. But this is the addition method. Essentially what you're going to do is you're going to start out, you're going to write your equation in the form ax plus by equals c. Remember, this was, we called this standard form, right? I think. Or general form. Probably standard form. I don't know. Standard, general. It doesn't really matter what form it is as long as you put it in that format. Basically, what we're going to do is we're going to add two equations straight down. And essentially, we're going to get rid of one of the variables by doing this. So, for example, if we had an equation like this, x plus y equals 3, and x minus y equals 5. The idea would be that we could add these straight down and say, well, x plus x is 2x, y minus y is 0, 3 plus 5 is 8. So that must mean that x equals 4. Alright, so that's our goal. Most of the time, however, you're not going to have this pretty plus y minus y thing. You're going to have to manipulate your equations so that they'll cancel each other out. So what you want to do is you want to multiply one or both equations by some number, and you can multiply the other one by a different number. So I'm going to say, or a different number. You'll know what I mean by that in a second. So I can multiply one number by 5, or one equation by 5, and the other equation by 3. It doesn't matter as long as I multiply the whole equation by the same number. I'll multiply one or both equations by some number so that either x or y will cancel out. That's the idea. Then I'm going to add straight down. So you go away. I'm going to add straight down. And whenever I do that, one or other of my variables will cancel. And then I'm going to solve for x and y. Best way that I can. So the way to do this really is to actually try this, because they're all going to be a little bit different. So we're just going to work a bunch of examples. Okay, so let's try this one. So we've got 3x plus 2y equals 48, and 9x minus 8y equals 24. So the idea is we want one or the other of the variables to cancel out when we add straight down. So pick one. You could say, well, I want my x's to cancel out or my y's to cancel out. So I'm going to pick my y's because I've already got a plus here and a minus here. So I'm like halfway there. Because I want them to go to 0. So the only way to do that is I have to add something and then subtract it out again. So I look at this and I say, okay, that's 8y. And this is 2y. Well, if I multiply 2 by 4, I'll get 8. So I'm going to say my goal for this one is to be positive 8y. Okay? And this is just something that comes with experience, honestly. This is just something that comes from doing it over and over and over again until you start to recognize these patterns. So if I want that to be 8y, what do I need to multiply this equation by on both sides to get the 2 to become 8? I need to multiply it by 4, right? If I multiply both sides by 4, then I'm going to end up with 12x plus 8y equals, whatever 48 times 4 is. It's 192. 192. All right. Now I'm going to take this other equation and write it right beneath it. 9x minus 8y is 24. And if I add straight down, get 12x plus 9x is 21x plus 0. That's what we wanted to happen. We wanted the y's to go away. Equals, oops. I should have put a negative sign. Do you care if I make this negative? You shouldn't, right? It doesn't actually change anything. Just remembering why I didn't get the same answer I've gotten every other time I work this problem, because that's a minus 24. It's just me copying the problem down wrong. I should say for a second here that pretty much all the time, that's not all the time, but most of the time when people get these problems wrong, even if they have the math right, it's usually because they copy the problem down wrong. So just be prepared for that. So this is going to end up being something with a 8 and a 6 and a 1, right? No, that's not right, is it? How about a 5? Would that work better? Am I crazy? I think I'm crazy. I think it is a 6. Hold on. I'm totally capable of subtraction. 192 minus 24. I'm going to take the 8. Doop, 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 doop. Look, see? Yes. Okay. I got it. There we go. So I've got 21x equals 168. Divide both sides by 21. And I get x equals 8. X equals 8. Yay! Okay. So now I can pick either one of the original equations and plug in x and solve for y. So I'll pick the first one because it looks easier. It has less big numbers in it. Okay. So 3x, wait, I know what x is. X is 8. 3 times 8 plus 2y equals 48. So 24 plus 2y equals 48. 2y equals 24. Y equals 12. So my solution is 8, 12. And so this is actually a really useful method because if you were trying to do this by substitution, for example, say, let me solve for the y. You get y equals negative 3x plus 48 over 2, and then you'd have to plug that into the 9x minus. It's just not a pretty picture. So when you're looking at these problems and it looks really awful to solve it by substitution, that probably means that you want to solve this by the addition method. Now, I put here as a goal of 8y, but I could just as easily have said, well, my goal here is going to be negative 9x and multiplied the first equation by 3. Then my x's would, by negative 3, then my x's would have canceled out. So you really can do this any number of ways, and you're going to get the same answer all the different ways that you solve this problem. So let's try another one and see what's going on here. There we go. There we go. Try, where's a good one? Try 5x minus 2y equals negative 1, and 3x plus 3y equals 12. Now in this problem, we're going to have to multiply both the equations by something, because I can't get from 3 to 5, and I can't get from 2 to 3, so I'm going to have to multiply them both by something. This is kind of like finding a common denominator, like when you're adding fractions. You're going to go through the same process. So you have to decide what variable you want to eliminate. And for me, I always, if I've got something with a minus sign and a plus sign, I'm going to go with eliminating that variable, because I don't like negatives, and I'd have to multiply by negatives, just like already ready to go, practically. So what I need to do is I need to figure out, okay, if this is a 2 and this is a 3, what's the common term that I need to get them all to equal to? So I'll say, well, I can get the 2y up to a 6y, and I can get the 3y up to a 6y. And if I do that, then when I add the 6y and the minus 6y, they'll cancel out. Alrighty, so that's going to be my goal. So this first one, to get it up to 6y, I need to multiply by, to get it from negative 2 to negative 6, I need to multiply by 3. So I'll multiply both sides by 3. And then to get the 3y to 6y, I need to multiply both sides by 2. So see, this is completely legitimate. You can multiply both sides of the equation by the same number, and it turns out okay. So I've got 15x minus 6y equals negative 3, and 6x plus 6y equals 24. Okay, these are equivalent equations. I've just multiplied them all by a big number. The reason I did that is because now, when I add straight down, I get 21x plus 0. If you don't get the plus 0 here, it means you did something wrong. Equals 21. 21x equals 21, so x equals 1. Now I plug it back into one of the original equations. I'm probably going to go with this one just because it looks, well, actually that one looks harder now that I've already written it, but I'm committed. So x is 1 plus 3y is 12, so 3y is 9, so y is 3. So my solution is 1, 3. You can kind of have a lot of fun with these kinds of problems. Now, just to give you an idea of what these problems look like, when you get so again, if nothing strange happens, that means that you have a solution, and it's whatever the solution is. But of course, we can still run into the no solution or an infinite number of solution options here. Say we had 4x plus 6y is 12, and 6x plus 9y equals 12. All right. So now we're going to have to pick which ones we're going to eliminate. And since we've been eliminating y so far, let's go ahead and eliminate x. So what can we bring 4x to and 6x to so that they'll cancel out? You bring them up to, think about it. If I have a 4 here and a 6 here, think about if I had 1/4 plus 1/6. What would I do to make a common denominator? What common denominator would I use? I use a 12, right? So you're going to use the same value there that you would use for a common denominator. So I'm going to make this one be 12x, and I want to make this one be 12x also, but one of them has to be negative, or they won't go away. So I'll make the bottom one negative. You can make either one negative, doesn't matter. So my goal is to make that 12x, and my goal, negative 12x, and my goal is to make that positive 12x. So to get that to be 12, I'll multiply by 3. And to get that to be negative 12, I have to multiply by negative 2. Okay? So I've got 12x plus 18y equals 36. And negative 12x minus 18y equals negative 24. Okay? You might begin to become suspicious. 12x and 12x minus 12x is 0. 18y minus 18y is 0 equals 12. 0 equals 12. What's 0 equals 12? Is this true or false? This is false. It's a lie. So since it's a lie, what does that mean? It means we have no solution. Yay, no solution. All right. So you can run, that's what a no solution looks like. It's the exact same thing. You're just going to end up with a mean, angry problem. Now let's try something similar. I'm going to use the same numbers. Just change one thing. So we still got 4x plus y is 12. 6y is 12. And then 6x plus 9y, but instead of making that equal to 12 also, let's change that to 18. So our goal for the top and the bottom is still going to be 12x, because we haven't changed anything else, right? 4x plus 6y. See, that's the exact same problem here. I just changed this 12 to an 18. Okay, so my goal here is 12x. My goal here is negative 12x. So again, I'm going to multiply the top by 3. Multiply the bottom by a negative 2. And get 12x plus 18y is 36. Negative 12x minus 18y is negative 36. And if we add down, I get 0 plus 0 equals what? 0, right? So z equals 0. Is this a true statement or a false statement? It's true! Yay! So since it's true, how many solutions do we let it have? Because it's such a nice little equation. Oops, I can't spell. We're going to let it have infinitely many solutions. Infinitely many solutions. I can't spell. Let's pretend I spelled that right. Alright. So that's kind of what those look like. Those are super fun. And you always like it whenever it's infinitely or none, because you never have to go back and solve for x or y. It's just like about 1/3 as long, because see all this extra writing I have to do when I actually get numbers. It's much better if everything cancels out and is ugly, because then you can just say, ha ha, this is my solution.